not allow me to continue that same broadcast. So I had to start a new one instead. All right, so we talked a little bit about the basics of programming in general, and most of our classes are going to follow a pattern a little bit like this, where we'll probably talk about some higher level concept or some more general concept along with the specific concepts of that day for JavaScript, so that you get more of an intro to the whole field, just a little bit of it, and very detailed introductions into the language that we're learning. So now we're going to dive into JavaScript. We're going to do a little bit of work with some of the different types of data that you can have in JavaScript, talk a little bit about reusing stuff, and then even create our first file. All pretty basic, and then we'll have a homework assignment that's a lot of sort of repetition to have you guys practice this stuff at home. So I think we've already started looking at some of this, namely, we've already started looking at a little bit of math, just using, it's funny, it doesn't let me zoom when I'm over there. Just using integers, right? So like 5 times 5, or 5 plus 5. And I would suspect that none of that looks too complicated to you right now. It seems pretty simple, like, oh, you just wrote out something and there's the result. The only difference from what you might be used to if you're using a calculator is I'm just sort of writing it all out on one line, and then something is processing that and interpreting it. So if we break down these most basic statements, like a 5 plus 5, we can actually go even more basic. The first most basic part of that is just 5. The programming language to JavaScript, this 5 by itself means something. It looks at that and it says, this is a number. So some of these commands I'm going to use to show you stuff, I don't expect you to know them just yet, but it'll help explain things, and we'll keep going through them over and over until I really introduce it as a concept so you get a better understanding of it. So I said that the programming language thinks this is a number. Let me sort of prove that to you. Type of 5 is a number. So it thinks that it says, oh, you put a number in. All right. So again, going back to that first line, we have 5 plus 5. So now we know what 2 parts of this line are. We know what 5 is, and we know what this other 5 is. Those are 2 numbers. Okay, that makes sense. What about this plus? Well, I mean, you're like, what is he talking about? We all know how to add. Why are we breaking it down this way? To a programming language, though, this stuff is important because the plus is a command. It's telling it, here's an action, or here's some sort of step to take. And it's saying, take this number and do whatever this action is, this command, the plus command, with both of these 2 numbers. Now, you can't really type of plus because it's not going to give you what you would expect. See, I get some sort of error there going on, because it's sort of a special command built into the language. So unlike a lot of other commands, it's not going to work quite as easily as, you know, we can't just do it like the 5 and just see what it is. Now you could do, I think this works. Oh, doesn't work, so. You could do it with some other stuff, but we'll sort of skip over a little bit of that, because that's not that important. The key part here is what's going on in the programming language. It's got a number, which we looked at. It's got another number, and it's doing an add action between them with this infix command of adding them. That's the same thing that happens with the star, except the star command in this case means multiply. And what that star command does, it says, oh, I take 2 number inputs, and I multiply them together and return the result of that multiplication. So it's returning the result. Just like the add here, return the result of adding the two numbers. Does that make sense so far? Pretty simple at this point, right? And you'll notice that these are just, they're of type number, like the 5 is type number. But there's actually some underlying information that isn't obvious when you just do this type of, and that is that this is just an integer. So inside the JavaScript itself, it sees that as an integer and not as any number. And the difference is, right, if we had like 3.14, that's not an integer, that's a floating point number or a decimal number, or a real number. Something like that might be the terminology that you're familiar with. Floating point is the most common in programming. And there's a little bit of a difference between the two, because if I added like 5 plus 5, I'll get 10 out, but with no sort of decimal or anything. But if I added 5.0 plus 5.0, oh, it sort of simplifies it here for me, I guess. Of course it does. But what it can do there is sort of floating point math, where it will give you back these decimal numbers as opposed to the full or just the integer number, right? So if I did like 5 plus 3.14, I get back that sort of decimal number, not just an integer, but it can do just integer math as well. And there's sorts of ways to have it work in those paths. So if I did, I don't know how to, I think this might do what I'm looking for. I think it's going to automatically do this for me right now, but we can, there's not a huge difference in JavaScript between floating point and integer math, unlike some other languages. There are some edge cases, but it's not as critical as it might be, say, in Ruby or something. So now we know, I mean, you know very basic stuff about how to work with numbers. You can also do division, and slash is the standard divide operator. And you can do, what else do we do? Multiplication, division, subtraction, of course. 5 minus 4. You'll notice there's no sort of requirement, like here I didn't have a space between the minus and the 4. The spacing is sort of all up to you. I could do 5 minus 4. It doesn't make a difference to it. It ignores all of the white space in the program unless it is required for it to understand that versus something else, which we'll get to later on, and you'll begin to get a feel for it. But in general, you'd want to just use like one space between commands like this. Yeah, you could write 5 minus 4, but I can show you where that would cause problems later on as well. So we've got some basic commands. We also have more advanced math commands that are built right in the language. Yes? I'm typing Command K on my system to do it, just so that it's easy for you guys to see what's going on. I don't know if there is a, I don't know if there's a command that you can just run inside of Node to do that. Control K, yeah, should be what it is. Well, mine's Command K, I guess, on my Mac, but Control K is probably what you would do on a Windows system. Any other questions right now? Dan's got sort of this weird knowing smirk on his face that's throwing me off. I saw it. I was like, where did this hello come from? Oh, you're messing with me. There's also more advanced math stuff that you may not be familiar with, but is very, very useful for programming that's built right into it. So for example, you can do this ampersand operator. or percent operator. Well, that's a little weird. Maybe I can write a few of these and I'll have you guys try and guess and see if you can figure out what it does. You know what? Let me write them the other way because I think that will be easier to understand. Any guesses based off this sort of pattern here of what this mathematical operator does? Yeah, it's basically remainder is what it's giving you. So it's doing 1 divided by 5, and what's the remainder of that? It's called modulus frequently in programming languages. So it's like 1 mod 5 might be the shorthand terminology. And that's very useful for a lot of different computations because it allows you to do a lot of really advanced things. Like, I mean, let's say one of the most basic is I want to convert time in hours that's elapsed since, like, if I'm just starting a timer on, you know, a Sunday morning at midnight or whatever, and I let it run all week. And so, you know, 67 hours has elapsed. I want to know what hour is it today? No, it's the 7th hour of the day or whatever. So I didn't have to do any advanced math to figure out what hour of the day it was. I just did this simple modulus operator to do that. And then some of the other ones that are built in, I hope this works, might not, but it doesn't just work like that. But there's some other math built in as well. Okay, so we talked a little bit about math with integers. We looked at some floating point work as well. So now let's talk about strings. Yeah, it's just decimals, or you might call them real numbers. So 3.14. Anything that's sort of a decimal number is floating point. And there is a reason, like I say, that's not as obvious in JavaScript, the difference between integers and floating point. But there is a reason that computers distinguish between the two. Without going into all of the detail, the answer is floating point numbers are just approximations. They're not guaranteed to be exactly that number. So I may not have the canonical example here, right? So let me if you look at that result, that just probably is very puzzling, right? Why isn't the answer to that 3.02 if I added those two numbers? Why did I get this 3.019999996 value out? And it's because, like I said, floating point in a computer are approximations. And so there's certain sort of edge cases that exist where you don't get out exactly what you thought you were getting in because of the way that the computer is doing that approximation. In a lot of cases, it works just fine. I think this one works. And you get back what you want. But there are certain edge cases where it's not. Whereas with integer math, with ones that have no decimals, it's always going to give you back the exact number, the exact result. And so you never run into that problem.
Anybody's just really into math and you don't understand why the computer has to estimate certain decimals, I would just go on YouTube or something and type in why float estimates or why decimals computer. It all actually, it's all because it's not a computer. It's not at the basic level using the zeros and ones. So it's not using a base 10 system. And that doesn't make sense. That's why I say just watch a video or something. It really, even if you're really good at math, it takes 10 minutes to start to understand.
I don't remember it. It's not something I have to deal with very often. And so it's not, I don't remember all the details of why that's the case and how the computer does it. It is, the one good thing about it is it's a standard. So pretty much every programming language, every platform uses the exact same standard for doing the floating point logic, which means that it has the same quirky behavior in every case. So they're able to, code around that exact same quirky behavior. You don't have different behavior in different environments. All right, so as I said, let's talk about strings for a little bit. And strings are something that, I mean, you guys use all the time, but you've never called them strings. Strings are just a series of characters together. So a string is hello world, or goodbye, or the road goes ever on and on. Like, each one of those is a string. And a string isn't restricted to just letters. This will be a little interesting, but 5 plus 5 right here inside of quotes, that's a string. You notice that unlike before when we wrote 5 plus 5 directly, we get back 10. Here, it's showing us just 5 plus 5. It just sort of repeated what we gave it. That's because it's not looking inside of this string of characters to do any processing. It just reads it as a string of characters that you want to write out or you want to save directly as that string. There's no special commands that it's looking for inside of there. So a string is just a group of characters. The way you create a string in JavaScript or the way you define it is with either double quotes around it, or as you see what it writes back to me, you can do it with single quotes. There's really not a difference. It doesn't particularly matter in JavaScript, unlike some other programming languages where they have a little bit of a difference between double and single quotes. However, some people prefer to use double quotes to quote their strings because you might write something like, don't go in there. And you can see I have a single quote in the middle of that. And if I use single quotes instead of double quotes for that and tried to spit it out, it created an error. And the reason it had an error was because when the programming language, when JavaScript is trying to find, oh, I see you gave me a single quote, so I assume this is a string. So let me go until I find the next single quote, and that'll be the end of the string. So it reads DON, single quote. Oh, so my string is DON. Okay. I've got a string of DON, but I have no idea what T go in there single quote is. That's not a command I understand. And since I already got this string out, the rest of this is read as commands to the programming language. And since it doesn't know what that means, it causes an error. That's why some people prefer just double quotes for them so that they don't have to work around that. Another option when you're working with strings is you can do something called escaping a character, which essentially tells JavaScript when it encounters it and it's trying to parse that string, oh, this is part of the string, not the end of it. Like this should be read not as some special command in the language, but as part of it. So if you were trying to do that, the way you escape a character in a JavaScript string is with this slash character, and you can see that that didn't cause the error. And that's because when JavaScript was trying to read this string, it started at the single quote. It said, okay, I've got a string. Let me get the entire string. So let me go to the next single quote in here. D-O-N, all right, no. Oh, I've got an escaped quote. So that is also not the end of my string because that's part of my string instead, and it makes it all the way to the end quote to put it in a string. That's something you'll need to get more comfortable with, but not a critical concept day one, escaping them. You'll get used to it sort of just through rote practice about what's going on there. So let me make sure I'm covering all the bits I wanted to. All right, we looked at the type of for a number. So what do you think the type of for a string is going to be? String? It's just string. And this type of, it's not something you need to know right now, but it's just a way to see what the type of anything is in JavaScript. So again, we did type of like 5 plus 5 as a string. It just sees it as a string as well, because we had put it in quotes. So it doesn't do any special processing of what's going on in there. So now that we've got numbers and we have strings and are already using this sort of type of operator, I'll introduce one of the core concepts of programming languages with those two, which is the idea of data types. So a programming language needs to know certain things about what you're trying to do in the language. And since languages, really programming is about, doing computation, doing things like that, but you also want to be able to have things like strings in it. And we talked about integers versus floats. For example, a programming language needs to know what type of object you're working with. And let me give you an example of why that matters. And if I did quote 5 plus quote 5, what do people think is going to be the result of this? Any guesses? Take a guess. What? Two good guesses. Anything else? Nothing? So we get a single quoted string out of 55. Does that confuse anyone? Is that the expected behavior? Is anyone surprised by that? I mean, it would surprise me because I would have expected to get 10 out, the number 10. Why did I get 55 out instead? And if we look at the actual output, we also see it's quoted, so it's a string. We got a string of 55 out instead of the number 10. Any guesses as to why? Yeah. It's because what it did was it concatenated, that just means combined those two strings together. But how did it know that it needed to concatenate the strings when I gave it the same operator to run, the plus operator? How did it know in this case to concatenate the strings instead of adding them together? Because it has quotes around them? Yeah? I mean, all that's right. The key part here in the language, I mean, you're all completely right on that stuff. The key is the language JavaScript has an operator, an add operator, that takes two strings and knows how to add two strings together. And what it does is concatenate them. And it also has an add operator that can take two numbers and add them together. So this plus can do different things depending on the data types being passed into it. It's flexible and it knows what to do with that data type. And that's sort of, I mean, that's not the only reason, but that's one of the core concepts of why you have data types, is so that you can tell it to take certain actions with these data types that work in the way that you would expect it to work. Because you definitely want to be able to add two numbers and get 10 out. And you probably want to be able to put strings together. Let's do hello world. All right, I put those two strings together using this plus or concatenator operator. I want to be able to do both of those, but it's really nice that I don't have to have some special different command, for example, that I put in here to say, oh, treat these things as, treat my inputs this way put them together this way every time. Instead, it's able to know, oh, I've got two strings, I can add them together. I've got two numbers, I know how to add two numbers. So that gets to the core concept of every programming language has these data types. In some programming languages, like if we go back to this intro to programming here, and we look at the Java code up here that we were looking at before, you see something, this int right here. That's just short for integer. So you notice in Java, we had to tell it explicitly, oh, these are integer types. But in JavaScript that we're working with, we didn't have to do that. We could just do 5, and we did like type of 5, and it just looked at it and said, oh, that's a number. So JavaScript has what's sort of known as like type inference or loose typing, where it tries to figure out the type of something that you're working with, as opposed to you having to explicitly tell it that type. And it does that through different means. Like the strings, it figures out it's a string because we put the quotes around it. So it can figure out this is actually a string that I'm working with. But that also leads to some interesting behavior sometimes. So now let's do one. And you guys have this stuff right in front of you. So what do you think the result of this is going to be? Or let's look through this line. Let's break down this line step by step together. What do we have here as this first sort of argument on this line? What? An integer 5, right? Because there's no quotes around it, it's just 5. And then we're saying add, do the plus operation. And then what's our second argument here? A string. So what do we think is going to happen? Error? You think it's going to what? 55? All right. What? An error or something? See what happens? We get 55. All right. And this is something that's sort of unique to JavaScript. I don't necessarily encourage this, but I just want to show you. It's doing some loose interpretation here. What it did was it looked at this 5, this string of 5, and this operator, and it said, okay, I know what to do with strings to concatenate them, but I don't know, this isn't a string. This other 5, that's not a string, so I can't just work with that. So what it actually did was it did, and this is stuff that you don't need to know immediately, but am I missing something? Maybe I'm missing the semicolon. So that should work. I don't know why it doesn't like that. I'll have to play with that in a minute. Maybe I have the, I just won't do it on a blank one. All right. So what it actually did was it sort of ran this toString command to get a string out, and then it knew how to combine two strings. Because it only knows how to operate on either two strings or like two numbers. It can't do, it would be sort of undefined behavior if you had to say, oh, these are two different things that I don't know how to work with. Think we get the same result if we do it the other way? A string of 5 and then the number 5? Yeah? We do. That's not always the case, and some of this JavaScript has some quirks there, but it does operate that same way. So we talked, all right, we've talked a little bit about data types. Now let's talk about how we can reuse this stuff, because what we have right now in our language, not that useful in terms of, we can't write a whole program of hard-coded numbers or hard-coded strings and have that make sense, because we'll have to write that same number all over the place. And plus, how would we ever be able to do a computation off of, if the user gives us something, how are we going to be able to know what that value is and use that for future computation? So every programming language has the concept of variables, which is a way to store a value, any value, so that you can use it later. And probably the closest concept that you guys would be familiar with in anything is has everyone done algebra of some level? Yeah, some sort of algebra. So you've seen functions, right? Like, and let's go with the very basic one, like x equals 2 is a function, and that x is 2 in an algebraic function. But you might have something else, an algebraic function that's like x plus x equals 4. And you need to solve for x, and you work it down and you say, oh, x equals 2 again, right? Because x plus x is 2x, and then I divide by 2 on each side and I get 2 out. Variables in JavaScript or any programming language are pretty much the same concept. It's just a place to store a value that you can then reference instead of using the hard value. You can use that placeholder to do computations. And the general way that you do that in JavaScript is var. The command is var, short for variable. So we can create the variable x and then assign it some sort of value. So we can assign it 5. And in JavaScript, a quick note, and I'll go through some very basic JavaScript items as well as we go through this, but lines, when you end the line, you end it with a semicolon. It's just a way to sort of tell it this is the end of the line, so that when it's interpreting, it knows to treat it as done as opposed to there being anything else there. So we get something interesting back from this one. It says undefined as our result of running that. And the reason is what it's printing out in this interpreter on each line is the result of the entire operation here. So this entire function being written, it says 5. Okay, the result of 5 is 5. We've seen that a lot. And then we're assigning that into the variable x. But the result of assigning something into a variable is just undefined. It doesn't give you back something off of that. However, the other thing we get out of it is now we have a variable that we can refer to and get back the value 5 instead of having to type 5 in directly. So now if we wanted to, say, add 5 plus 5, we could do x plus x. To get back 10, because when JavaScript's running through this line, it looks at x, and it says, oh, this looks like a variable name of some kind. So do I have a variable x? I do, and it has the value 5. So replace that with 5. And then what about this x? Oh, yep, variable x, replace it with 5. And then just add those two. Does that make sense to everyone? All right, so let's create another one, variable y, and let's give it a different value. Anyone have a favorite number? 2? All right, I didn't put my semicolon there, but the language is a little nice. It'll try and do that for me if it can. So now we can do y times 5, or times x, for example. It should give us what's that? 10? Yeah. Because it's just replacing those values as we go through. So now let's create another one. I'm going to create a variable with a longer name because you can use any word that's not a reserved word in the language, like var, for example, as your variable name. So you can't use those because the language would try and interpret it special. And we'll talk about what those reserved words are over time. But var5 equals, I put the string 5 in there. So now, what do we think the result of this operation is going to be? What? Air? What's that? 55? All right, let's walk through it. Let's sort of step through it bit by bit. So what is in X? Do we remember? I can bring it back up so we're familiar with it. So the way this interpreter will read this is, what's the value in X? 5 as a number, right? And then what's in 5? The string 5. So now you could imagine this line as 5 the number plus the string 5, which we have already seen before, which was 55, the string. Because all it's doing is replacing those with the value that they have and then doing the computation with those actual values. Does that sort of make sense? Yeah?
Then just I know Jared said that one thing to is that, like Jared just said, that doing variables, programming, one thing that's that looks very different than with like algebra, since most of us have only seen variables in algebra, is that fact that Jared said that you can name your variables just about anything. And right now you're just starting off with stuff really basic, but eventually you will usually want to name your variable something that describes what the variable is. And I only mention that again, like I'm sure Sarah will point that out many times in the future, but I think it's good to emphasize because I know for me, like as a beginner, I actually get confused sometimes when I see that. I'm like, hey, what is this? What does this word mean? And I don't realize that it's just like the random word that somebody decided to call their variable. Because you think all the words must have some other meaning. Most of us are used to seeing our variables be like A, B, X, Y. We're not used to seeing variables that are actually called like total or amount or whatever it is that you or maybe writing a program that keeps track of profit and business, so the variable might actually be profit. Something to watch out for.
Yeah, I think that's a good point. We'll definitely go over it as we write larger programs, but meaningful variable names make a big difference when you're writing larger code, and especially when you're reading it. Because if everything was X, Y, and Z, it's almost impossible to know what that variable holds without reading everything around it. Whereas if it's like this, for example, sum equals X plus Y, well, I think by just looking at the variable name sum, you might have a good idea of what that variable holds, right? You get a feel for it. All right, that just holds the value of X plus Y. Another thing and this is where one of the biggest differences is between an algebraic variable and a programming variable, is that in almost every language, JavaScript included, you can reassign to that variable. You can give it a new value at any point in time. So, and it doesn't change. This is where it starts to get a little confusing for people. It doesn't change any previous computations done with it, because it's only computations after that that it looks at it again and tries to find the new value. So for example, y right now is 2. We can make y a new value. We don't have to do var y again, because sort of that var y was a declaration saying we're creating a variable. Now we already have the variable y. It exists. So instead we can just type y equals, and we can give it a new value. Somebody else have a favorite number? Anything? 7? All right. So now y has the value of 7. Now, do we think that's going to change the value in sum because sum was computed as X plus Y? No? Yes? Who's for yes? It's going to change the value of sum. All right. Who thinks it won't? Yeah. It's got the same value that it had before. It's got 7. And the reason is, and I wish I had more whiteboardy stuff here to explain this. I'll probably do this in a future class where I can whiteboard it out a little better. But the value that sum is pointing to didn't change. It was computed at one point and saved, and it just sort of holds on to that value from now on. But if we recomputed sum, if we change sum now to be x plus y, you can see that now sum does have a new value because it's reading the value of y this time when it does the computation.
I don't know how good it works. It's supposed to be a whiteboard, but
yeah.
Just testing.
So this is going to be one of the most core concepts of programming, is working with variables, assigning things to variables, changing the value of variables, and using that to do computation. If there's any questions around this over the whole course of the class, just bring it up. We'll go over this stuff again and again because we definitely need to get this down for everyone so that we feel really comfortable and confident in working with variables. We may not get to writing a hello world file today. I think I just want to spend a little more time going over variables instead, since we're sort of at the end of class time, so that we can emphasize this a little more. And that's probably what I'll work with for more of your programming assignments or whatever, as well as just sort of working with variables, setting some values. Are there any questions or thoughts around it? Is there any part that you're thinking, I'm not sure if that would be clear to me right now? Yes? Yeah. Quotes as well. That's a good question. Let's try it. And this is something that you're probably not going to do very often, to be honest. You're not going to be concatenating integers and strings and stuff like that. But it is possible. And it just sort of concatenates them in that way. Any other questions right now? All right, so let's talk a little bit more about variables. Yeah, I could whiteboard something up there, but the basic idea behind variables and how they're working in your program or in your code. It's a little bit like this. I don't know if people can everybody see this space right here? Okay. So the basic idea of what's going on, of course this marker doesn't work. I'm going to try and grab another one over here. I'll just grab a ball. Black one actually looks good. So the basic idea of what's going on in your program with variables is, if you think of all the memory in your program, you'll have this other location where you've got sort of these variables defined. X and Y and sum and anything else that you want to assign to the variable. And those sort of point to this location in your program which has a value. So X is 5 and Y points to 7. And then when you compute sum, what it'll do is it'll look at X and go get the value that X has. And it'll look at Y, go get the value that Y has. And then add them together and put that in a memory location in the program for it to reference and work with. And that's one of the reasons why I was saying like the value doesn't change for sum, because it's sort of referring to this value that's there. Whereas if now we change y, well, y will change and its value becomes 42, for example. And if we recomputed sum, it would go and get these two values and then change what's stored in here to give you the sum of that. And put it in the location that sum is going to reference from then on. So variables allow you to work with these different memory locations in your program and do very powerful things in your code. And that's, I guess, really the core of being able to do anything dynamic. Because if you were just going to write some basic computation, you already know all the values, that's easy. But if you want to take two values from a user and add them together like a basic calculator, you've got to be able to store those somewhere and store the results. And if we want to keep adding stuff, so let's say sum keeps adding, well, you need to be able to do that as well. A couple other details since we're talking about variables, and then we'll sort of wrap up, is a variable can refer to itself as well. When it's reading the value is different than when it's assigning. So the equal sign assigns a value to your variable. But we've seen them be read too, like if I just type X or Y, I'm not assigning a value, I'm just reading what's in it. And that's different, or sum, that's different than assigning it. So if I did X equals 42, I assigned a value. Well, in the same line, you can both assign a value to a variable and read a value. So let's say sum, we want to make sure that every time we add a new value, we add it onto the existing sum. We don't have to rewrite all of our items. We can just do sum equals sum plus X, or plus 42. And the way this line breaks down, if you're trying to break it down in code, which is the way I recommend you think about stuff, especially at first, is what's going on step by step here, is first it looks at the value of X, which is 42, and gets that, and then it looks at the value of sum, which is, I don't know what it was 12. And then it adds those two together and puts it into the sum variable. So first it read the value out of here and here, and then it rewrites the value in that sum location. So you can both read and write to that same variable in the same line of code. Does that make sense? That's a very common pattern. You'll encounter it a lot, especially when you're doing something like just incrementing something. So if we had like a var increment, we want to just increase it every time something happens. So increment equals increment plus 1. And we can rerun that. And each time it'll read the current value of the increment variable, add 1 to it, and store it back in itself. Does that make sense? Are we good on that? A little confusing, maybe? Again, this is one of the big distinguishing differences between, say, algebraic variables and programming variables, is that you can reassign them, and as a result, you can both read and change them even in the same line and work with them in that way. All right? So if there's no questions about that, I think are there any questions about anything we covered so far? All right. I'm going to go ahead.